Hey everybody. We just realized that problem number 57 was way harder than I intended it to be. So I'm going to kind of throw the solution up here so you can kind of see what it is. It's definitely solvable, but it's way harder than anything I'm going to ask you to do on the little kind of end of chapter assessment we'll do here. So I just wanted to do the quick solution for it so you can kind of see how it's done. There's two tricks to this problem. Number one, the trick is to keep in mind what happens when you've got components of something at a 45-degree angle. And then the second thing is to be able to be comfortable enough to leave something as a variable kind of for this particular problem. So first thing, when you're talking about we're launching a baseball here at a 45-degree angle, and we know it's clearing this wall at 98 meters on the other side. So we know we're trying to figure out what VI is, and we don't know anything about it. The key thing here is to realize that if you've got a 45-degree angle, that means I know that my X and my Y components have got to be the same. VIX has got to be equal to VIY. And that's because, again, it's at a 45-degree angle. The horizontal and vertical components are the same. We know a couple other things about it too, like that horizontally it's still going at the constant speed, vertically it's still accelerating and doing the kind of usual stuff to it. So here's how I solve this one. I'm going to look at that. I'm going to look at that horizontal component of its motion first. Hold on, I got to get my eraser here. Sorry, my bad. I'm going to do the VIX equals dx over t. Horizontal component, because that's the only other piece of information I have here, something about its horizontal motion. I know that VIX is got to be equal to 98 over time. Now, I don't know what time is, so that kind of sucks. And that's the piece I know I'm going to need. So I'm going to solve this for t. 98 divided by VIX. And I'm just going to leave it like that. I don't know what the value for t is because I don't know what my value for vi is. That's eventually what I'm trying to find. So that's kind of our x component. If I look at our y component motion, I'm going to take advantage of a second piece of information. Vf equals vi plus a delta t. I know that if something's taking off and landing, that VF and VI are the same, just opposite directions. So if I'm going to talk about this, I can say that negative VI equals VF, right? If I'm talking about when it's taking off and landing and it's projectile motion, and now I'm talking about in the Y direction, I'm not talking about the X direction, this is Y's. I know that it's taking off at, +7, it's going to be landing at -7. And I'm going to take advantage of this in this equation to get rid of a couple of variables. So I know that this is going to be negative VIY equals VIY plus acceleration's negative 9.81. And then this is t. So now I have, if I start doing some algebra on here, I'm going to move this to the other side. I get negative 2 VIY equals negative 9.81 delta t. If I keep solving this thing around, I'm going to divide both sides by 9.81. I get something like 0.2 VIY equals t. Hi, cat. Move. We don't need your butt in this. Come on, out. Yes, shoo, out. So now I've got a second set of variables. So I know 0.2 VIY equals t. So now what I'm going to do is I'm actually going to take both of these two equations, this one and this one, and I'm going to combine them together, cat. And what I'm going to end up doing here is kind of cheating a little bit. I'm going to take this equation over here, the VIX, and I'm going to stick it in this equation. Now I want to remind you, VIX equals VIY. Remember, this is at a 45-degree angle. So I can still say that that t equals 98 divided by VIY, because VIX and VIY are the same thing. So now I'm going to take this and plug it into here. 0.2 VIY equals 98 divided by VIY. Again, I've taken this and I'm substituting up into that section right there. And so now it's kind of algebra. I'm going to move both sides, multiply VIY by both sides. So I get 0.2 VIY squared equals 98. VIY squared equals 98 times 0.2, which is 490. Again, I'm kind of getting kind of sloppy about this. 98 divided by 0.2 is 490. And then I take the square root. I get VIY equals 22.13. So again, I divide both sides by 0.2. 98 divided by 0.2 is 490. And then because this is VIY squared, I just took the square root of it, get 22.13. Okay, this still isn't our VI. I'll go back to our original problem right here. Remember that VI is at a 45-degree angle. I now know some things about it. I know that this side here is 22.13. I'm looking for VI. It's at a 45-degree angle. So if this side here is 22.13, this side here also has to do 22.13. And now I can just use Pythagorean theorem. A squared plus B squared equals C squared. So it's 22.13 squared plus 22.13 squared. Take the square root to get VI. And in the end, I end up using, again, with Pythagorean theorem, VI equals 31.3 meters per second or something along those lines at a 45-degree angle. So anyway, that's just the quick solution to it, just so you can kind of see where they're coming from. It's a pain in the butt. Don't worry about it. If you do it, great. If you don't do it, also great. Not going to give you one this hard. If I do or when I do the little performance assessment for this chapter, it'll be two straightforward problems. One will be something launched horizontally off a cliff, and the other one will be launched from the ground at an angle, not like this, where I'm going to give you some kind of weird variable. So there you go. Like I said, don't worry about it. All is well, and see you guys soon.